Alright, 8th graders, this is 5-2B part 2, and we're kind of going to pick up where we left off after part 1. Now we're on example 6. Again, I encourage you to try this. A train travels at 12 miles per hour. In fact, at one time, that was considered the speed limit for trains back in the early 1800s or in the 1800s. So if you traveled at that speed, how many yards per minute would this be? So at this point, I encourage you to hit pause, try it yourself, and then I'll show you how to work through it. Okay, look at what I've done. How did you do? We really don't have a conversion on page 248 for, I think it's 248, for miles and yards. So I went to feet first, and then changed it to yards. If you do want to use a conversion, what you can do is take 5,280 divide by 3, and you're going to get 1,760 yards per 1 mile. So we could use that in the future, but at this point we really can't. Now, actually, if I were going to do this problem, I would probably try to cancel as much as I could. If I cancel labels, this miles cancels miles. This feet will cancel feet. So there I've got that yards. That's got to be my top or my numerator. Then hours is way over here to cancel hours. And I've got minutes down here, which is in my denominator. Now at this point, I would roll it through a calculator. What I would do is take 12 times 5,280, divide by 3, divide by 60, and to be perfectly honest with you, I would go ahead and cancel this 3 and this 12 to make it 4. And I would take 4 times 5,280 divided by 60. Or you can do the multiplication method. You're going to get 2,120 over 60 if you don't cancel, okay? And that's going to be 352 yards per minute. And hopefully that's an answer that you got as well. Okay, we're going to move on to example 7. Yes, I have a lot of examples. This is why I'm doing the lesson over 3 parts. Again, hit pause. You try it. And then I'll show you what it should look like. Again, always thinking, got a reason, because you really can't follow some sort of a process or a pattern here. I'm looking to get my numerator from miles to feet. I know that if miles is in the numerator for 60 miles, I'm going to have to put a mile down in the denominator so that it will actually kind of cancel. This miles will cancel miles. Canceling labels is a big help. So then I know that there's 5,280 feet in a mile. Feet is in that numerator position over here, and yes, I've got it in a numerator position over in my problem. Now I want to get the seconds, and if you remember in part 1, we said that there are 3,600 seconds in an hour. So I'm going to use that conversion factor. And the hour was down here in a denominator position. I need to have an hour in a numerator position so I can cancel it. That means my seconds has to be in the denominator. And if I'm going to multiply this out, I will get 316,800 divided by 3,600. Again, what you can do is go right to 60 times 5,280 and then divide by 3,600, and you will get 88 feet per second. So if you are traveling in a car at 60 miles an hour, 88 feet per second. That's one of the reasons why they tell you not to follow too closely, because it takes you a long time to slow a car down. You're still going at 88 feet per second. That's over almost 3 times the width of my classroom in 1 second. All right, again, try example 8. Okay, how did you do? Did you get that? 16 ounces for the conversion factor. Remember, we're not working with fluid ounces, so we need the 16. And it's not on that conversion table, but I hope you know that there's 365 days in a year. No, we don't factor in a leap year. We just usually use a regular year of 365 days. And this boy would have gained 80.88 ounces per day, which means not even an ounce a day. Let's try number 7. This is actually true, and this one's from the metric, so you're going to have to work on that metric table. The speed limit in the Netherlands, at least on most of the highways, is 110 kilometers per hour. Now, a kilometer is a little less than 3/4 of a mile, so you're roughly traveling at about 75 to 80 miles per hour if you're converting that. Now, we want to know how many centimeters per second that is. So here's where we have to figure out whether or not we truly know our metric system. All right, we have 110 kilometers per 1 hour. Again, I always start with the top. I don't know why, I've just always done it that way. We want to get to centimeters on the top. Well, if you look on your table for conversions, we really don't have a conversion that takes us directly from kilometers to centimeters. We'll probably have to go to meters first. Now, where's this kilometers? Yes, it's in the numerator. So where do we want to put it in order to cancel? Yep, it's got to be in the denominator position. And we know that there are 1,000 meters in 1 kilometer, because that's the conversion factor that we are given. Now what that's going to mean is my kilometers will cancel out my kilometers. Now, I'm still not where I belong, because I need centimeters. And remember, it's got to be in the numerator position, but I'll need meters in a denominator position in order to cancel out that label of meters. So my centimeters has to be here. We know that 1 meter is 100 centimeters. At least I hope we know that. And then my meters will cancel my meters out. Now I've got centimeters in a numerator position. Well, now I can go back and I have to deal with that denominator of 1 hour. It's got to be in a numerator position for it to cancel. And I know that 1 hour is 3,600 seconds. And now notice the seconds is exactly where I want it in a denominator position. You could do some canceling here as well. If you multiply it all out, you're going to get 1, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6 zeros from the top. Yep. And we're going to get 3,600 down here. Now we could actually do a little canceling of the zeros, or we could just go right to the calculator. By canceling zeros, this and this 0 would cancel, so would this and this, because that's dividing, this one's dividing by 10, this one's dividing by 100. Now I can just put in the 110,000 divided by 36 into my calculator, and it comes out to 3,055.56 centimeters per second, which basically means that in 1 second you're going a little bit more than 300 and something meter sticks, over 300 meter sticks. Okay? Now, what we've done so far in parts 1 and 2 should be able to take you through the first parts of worksheet 5.2b. You should now be able to get through Roman numeral 1 on worksheet 5.2b. And at this point, I'm going to say scouting out, but don't forget to come back for part 3.